For the following function, identify any horizontal and/or vertical asymptotes. Then, if possible, use technology to graph the function and verify your results. Notice first of all that our function is a rational function. F of x is equal to the polynomial 3x minus 13 divided by the polynomial x minus 4. Notice also that the rational function is in lowest terms. X minus 4 is not a factor of the numerator. Therefore, to find any vertical asymptotes, we can simply set the denominator equal to 0 and then solve for x. When we set the denominator equal to 0, we get x minus 4 is equal to 0. Adding 4 to both sides gives us x is equal to 4. So x is equal to 4 is the only vertical asymptote of this rational function. To identify any horizontal asymptotes, we'll compare the degrees of the numerator and the denominator. If the degree of the numerator is less than the degree of the denominator, then the x-axis, or y equals 0, is the horizontal asymptote. If the degrees of the numerator and denominator are the same, then y is equal to the ratio of the leading coefficients is the horizontal asymptote. And finally, if the degree of the numerator is more than the degree of the denominator, then there is no horizontal asymptote. Well, in this case, the degree of the numerator is 1 and the degree of the denominator is 1. The degrees are the same. So to get the horizontal asymptote, we'll set y equal to the ratio of the leading coefficients. The leading coefficient of the numerator is 3, and the leading coefficient of the denominator is 1, so the horizontal asymptote is y is equal to 3 over 1. 3 over 1 simplifies to 3, so y is equal to 3 is the equation of the horizontal asymptote. Let's use a graphing calculator to graph the function and verify our results. We go to y equals to enter our function. Make sure that you enclose both the numerator and denominator in parentheses in order for the function to graph correctly. To get a good viewing window, we can go to Zoom and select Zoom Standard, number 6. Let's first of all check and see if it seems reasonable that x is equal to 4 is a vertical asymptote. When we draw a vertical line at x is equal to 4, we see that the function increases without boundary to the left and decreases without boundary to the right. This means that f of x approaches infinity as x approaches 4 from the left, and f of x approaches minus infinity as x approaches 4 from the right. To reinforce this idea numerically, we can create a table of values. We'll go to Table Set, second window, and change our independent variable to ask. We'll then go to Table, which is second graph, and we'll enter values of x that are approaching 4 from the left, values of x that are a little bit less than 4. So let me try 3.9, 3.99, and 3.999. Notice that as x approaches 4 from the left, the values of y are increasing, and it appears that they're increasing without boundary. Since f of x approaches infinity as x approaches 4 from the left, we can safely conclude that x is equal to 4 is a vertical asymptote of the function. Let's see if it seems reasonable that y equals 3 is a horizontal asymptote. When we draw a horizontal line at y is equal to 3, we see that the function approaches 3 regardless of whether x decreases without boundary or x increases without boundary. To reinforce that idea numerically, we can revise our table of values. Let's see what happens as x increases without boundary. We'll start off with x is 10, and then 100, and then 1,000. Notice that as x gets larger and larger, the y values are getting closer and closer to the number 3. Since f of x goes to 3, as x goes to infinity, we can safely conclude that y is equal to 3 is a horizontal asymptote of the function.